In this video, we're going to start looking at coordinate geometry. To begin with, we'll do some revision of the basics, and then in later videos, we will look at the equation of a circle. Let's start off by looking at circle parts. I'm going to draw up a circle, and then I'm going to draw on a diameter. The diameter is a line that goes from the circumference to the circumference and passes through the centre. So if we go ahead and do that, we can just write that this is a diameter. I'm now going to draw a radius. A radius is a line from the centre to the circumference. The radius is half a diameter. So if we put this on, we've got a radius just here. Now that radius could be here, it could be just here, it could be anywhere from the centre to the circumference. I'm now going to draw a chord. A chord is like a diameter in the fact that it goes from circumference to circumference, but it doesn't pass through the centre. So this is called a chord. A chord forms a segment. If we have a radius and a radius, or two radii, we end up with a sector. So this is a segment, this is a sector. I'm now going to draw on a tangent. A tangent is a line that touches the circle. So this is a tangent. So let's go ahead and write that on. So this one is a tangent. When we have a tangent and a radius, which we'll look at in later videos, we have a 90-degree right angle. So the radius and the tangent meet at 90-degree right angles. I could have had another tangent over here, so let's just put one on there. It could have been like so. We could have had one just there. They are simply now lines that are touching the circumference of the circle. Throughout this unit, I'm going to suggest that if in doubt, sketch it out. So if you're unsure, just draw a quick drawing. What we're also going to look at is the midpoint of a line segment and also the length of a line segment. We've seen this in previous units. So we can write the midpoint, if we just jot this down, as x1 plus x2 divided by 2. And then we'll have y1 plus y2 divided by 2. All this is telling me is to add the x coordinates and divide by 2 and do exactly the same with the y's. This is just the average of the two coordinates. The reason we're going to be focusing on the midpoint is when we come to a circle, often we use the midpoint to find the centre of the circle. Let's now look at the distance formula, or the length of a line segment. So if I wanted the length of a diameter, we could write now the distance, or the length, will be the square root of x1 minus x2 all squared, plus y1, so y1 minus y2 all squared. And that will tell us now the length of a line segment. We've seen this in a previous unit and it's relatively straightforward. So in this video, we're simply going to focus on midpoint and distance problems. In later videos, we will look at the equation of a circle in the form x minus a all squared plus y minus b all squared is equal to r squared. So if you think you're comfortable with this particular set of formulae or the application of them, you might want to go on to the next video and just look at the equation of a circle. So let's go ahead and answer some questions. In question 1, we're asked to find the midpoint of the following points. So in A, we've got 3, 7 and 1, 3. So all we're doing is adding the x's together, 3 plus 1, dividing by 2, adding the y's together, 7 plus 3, and we're going to divide by 2. So that's going to give me 4 over 2, which is going to give me 2. And then we're going to have 7 plus 3, which is 10. 10 divided by 2 is 5. So why did we do this? Well, let's say we had a circle, and I just draw a circle up. What we've got is something that looks like this. Now, if I had the point here, 3, 7, and 1, 3. So let's put this just here. Let's say that this is going to be 1, 3, and this one is going to be 3, 7. in finding the midpoint, we could have found the centre of a circle if it passes through those 2 points. So that is the advantage. So this point right here is going to be 2, 5. From that we could work out now the length of either the diameter or the radius. Okay, let's have a go at the next one. So what we've got then is -2 plus 4 divided by 2, and then we're going to have 3, let's put that in, 3 plus -3, or simply 3 minus 3 over 2. So this is going to give me 1, 0. So that now is the midpoint of these 2 points. If we look at the next one, we've got 1 plus 7 over 4. I'm going to write this as 4 over 4 plus 7 over 4 divided by 2. And then we're going to have now 3 over 4 minus, I'm just going to write this now as 8 over 4. So 8 over 4, and that is over 2. So we can see that this is going to give us 11 over 4 over 2, which is 11 over 8. And then we're going to get -5 over 4 over 2, which is -5 over 8. If you're unsure, you can simply put them through a calculator. So if you wanted, you could write in here 1 plus 7 over 4, and then divide this now by 2. So divided by 2, and that will give you answer. And you could do exactly the same with the other one. You could put 3/4 or 0.75 minus 2, and then simply divide this by 2, and that would give a -5/8. So if you're unsure, simply use a calculator. In question 2, we're asked to find the length of a line segment AB for the following. So we've got A and B just here. So all we're going to do is say that AB will be equal to the square root. So what we can do now is either 1 minus 2 all squared, and then 3 minus 5, or the other way around. It really doesn't matter. I'm going to do 1 minus 2. This is now the x, so if we wanted to call this x1 and this x2, it's going to be 1 minus 2, which we need to square, plus now, and being consistent, I need to do the 3 minus 5. So 3 minus 5 all squared. So this is going to give me now -1 squared, which is 1, and -2 squared, which is going to give me 4. That is going to give me the square root of 5. We could give that now to 3 significant figures. I'm just going to leave it as it is. So if you wanted to do it straight through the calculator, you could have simply put now in here the square root of 1 minus 2 all squared plus 3 minus 5 all squared. I'm leaving my answer now in exact form, or as a third, and that is what we have. To 3 significant figures, 2.24. So exactly the same as we've seen in the previous unit, we're simply going ahead now and writing this out. Okay, let's do the next one. So I'm going to write on the next one, this is part B. AB is going to be the square root. So we're going to have -3 minus 2, which is going to be -5. And I'll just write this as -5, plus we're going to have 2 subtract -5, which is going to be +7. So that's going to give us now the square root of 25 plus 49. And we can write this now as a square root of 74. So that is equal to the square root of 74. Let's just pop that in, square root 74, and that is exactly as it is, as we would expect. So I'm just going to leave it like so. Okay, let's look at question C. So what we've got here is 2 and -1. So this is going to be the square root of now 2 minus the -1, which is going to give me 3, which we need to square. And then we're going to have 0.5 minus 3, which is going to give us -2.5, which we need to square. So that's going to give me the square root of 9. 2.5 squared should give us 6.25. So that's the square root of 15.25. We can go ahead and look at that. Let's do that. 15.25, see what that gives us. So square root of 15.25, and that gives us root 61 over 2. So root 61 over 2 in exact form. Okay, in part D, it says, given that the line segment AB is a diameter of a circle, state the radius of each circle in questions A to C. Now, what these essentially say, and let's just draw this up. In fact, let's just do the last one that we've done. So what we'll have is something now that looks like this. So let's put on here, so we'll put this point right here. This is going to be the -1, 3, and then we'll have this point right here, which is going to be 2, 0.5. So this is a rough sketch. It doesn't have to be massively accurate. What we've just done is found the length of the line segment. So if I just go ahead and put that on, what we've got is 61 over 2. So all I need to do to find the radius is simply half that. So this is going to be root 61 over 4 and root 61 over 4 because a diameter is double the radius. So I've just halved this answer to get the radius. This is the diameter, or AB, and the radius is half of that. So if we go back, this would be root 74 over 2 and root 5 over 2, and that would give us the length of the radius. So as stated, if in doubt, sketch it out. Your diagram doesn't have to be massively accurate. It just gives some idea of the situation we're trying to model. Okay, question 3. The points 2, 1 and -2, -1 are the end points of the diameter of a circle. In part A, we're asked to find the centre of a circle and the length, in part B, the length of a radius. We certainly don't need to sketch it, but as we're doing it, I'm just going to put it on. So what we'll have then is the following. We'll have 2, 1 and -2, -1. So if we put this one just here, so -2, -1, and if we put this one just here, which is going to be 2, 1. So if we just consider what we've got the diameter. So the centre of the circle will be halfway in between. So all we need to do is find the midpoint. So I can see what that's going to be from here, but I'm just going to go through the process. So I'll call it centre, and what we'll have, the centre will be the following. We'll have -2 plus 2 divided by 2, and -1 plus 1 divided by 2. We can see that this is simply going to give us 0, 0, and that is the centre. When you move on with your work, often this is quite intuitive in terms of doing this. You can see what it's going to be because the difference is going to be here 4. Half of that is going to take me to 0. The difference is 2, so I'm adding 1. Don't be afraid, as long as you're showing workings, of moving away from the rigidity of formulae. Certainly when you come onto the equation of a circle, to be able to just draw things and have some geometric understanding can really help certain situations. Okay, we need to find the length of a radius. Now, I've got here the endpoints of a diameter. The best thing for me to do would be to work out the length of the diameter and half it. The reason being, if I've got this centre point wrong, working out the length of a radius means that that will be wrong. I'm going to do it both ways just to show. So the diameter is going to be now the square root of 2 subtract -2, which is going to be 4, which we need to square. And then we're going to have now 1 subtract -1, which is going to be 2, and we need to square that. So that is going to give me 16 plus 4. That is root 20. We could simplify this to 2 root 5. So that's the diameter. Now from this, I should expect the radius to be root 5, 1 root 5. So the radius is going to be the square root of 0 subtract -2, which is going to be 2, which we need to square. And then we can have 0 subtract -1, which is going to give me 1, which we need to square. So that's going to be the square root of 4 plus 1, which gives me root 5. So that's all I've done. I've simply gone ahead now and shown that the diameter is in fact twice the length of radius, and this quick sketch might have helped. Certainly don't need it, but it gives you a bit of intuition on what's going on. Okay, question 4. In part A it says the point 1, 5 over 4 is a point on the circle C. Given that the centre of a circle has coordinates 1.75, negative 1, find the coordinates of the point B such that AB is a diameter of the circle. So lots of words here, but a nice little sketch will show us that we're just working this problem backwards. So let's go ahead and put this one on. So we got 1.75. Now if I think about 1.75, we could of course write it like so, or we could write this now as 7 over 4. It really doesn't matter. So we've got now the centre, and that's 1.75, comma, let's make that look like a 7 rather than a 2, comma, negative 1. With this one right here, what we're going to have is the point 1 and then 5 over 4. I'm going to put that just here. Now it doesn't matter that that isn't perfectly accurate. This is just the point now A. So if we put A, we've got 1 and then we've got 5 over 4. So what we've got is the halfway point. So we need to find the point B. The point B is going to be here. That is the diameter. So a couple of different ways that you can do this. I can see now that this is the midpoint. You can either do it using the midpoint formula and call these coordinates x and y, or simply jump up. I can see that I've increased this by 0.75. So that's halfway, and all I'm going to do is increase it by 0.75 again. So that should give me 2.5. This is 1.25, and this now is negative 1. So if you like, I've gone down by 2.25. So this one should be negative 3.25. That should be the point B. So if I look at this 1.25, we've gone down to 0 and down another one. So that's going to be negative 2.25, and I've subtracted it. Alternatively, what I could have done is said that the midpoint was equal to 1.75 and then negative 1. So that is the midpoint. So if we look at the x coordinates, what we could have said is now 1 plus the x coordinate divided by 2 is equal to the 1.75. And if we multiply through by 2, we've got 1 plus x is equal to 3.5. So x must be equal to 2.5, and that's the x coordinate just here. So I'm using the formula. If we then look at the next one, what we could say is 5 over 4, or 1.25, that's 5 over 4, plus the y coordinate divided by 2 will be equal to negative 1. So all I'm going to do is multiply by 2, 1.25 plus the y is equal to negative 2, subtract the 1.25, y is equal to negative 3.25. So I've shown it using the formula, and I've shown it geometrically by just essentially jumping up. So I've jumped up, and I've done the same by adding it on. In part B, we need to find the length of a diameter AB to 3 significant figures. Now at this stage, I could use these values. Alternatively, I could use the information that I'm given, which is now the point on the circle, and the centre, find the radius and double my answer. I'm going to show it using the radius. So the radius is the square root of 1.75. Remember, this is x1, this is x2. 1.75 minus 1, which is 0.75, which we need to square, plus we've got now minus 1 or negative 1, subtract now the 5 over 4, which is going to be now negative 2.25, which we need to square. So just finding now the square root of this. So we've got 0.75, let's do that. So 0.75, which we need to square, plus, and then what we're going to have is negative 2.25 squared. So I can just put plus 2.25 squared in, and that is going to give me now the 3 root 10 over 4. Now that is the radius, so 2.37, which is 2.37 dot 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 dot. So all I'm going to do now is multiply this by 2, and that will give me the diameter. So that's going to give me 4.74. So the diameter is going to be 4.74 units. We're not given a measure, it's just units. And that is to three significant figures, 2, 3, SF. So that's all I've done. Now what I could have done is done the whole thing using this information. So I could have done in here the square root, and if you're uncertain, you can just type it in. So it would have been the 2.5 minus 1, which we would need to square. That is the change in the x's. And then the negative 3.25. Subtract now the 5 over 4. So let's just 5 over 4. And we need to square that. So you can see if you're unsure, you can just plug it in. And that will give us what we expected. Let's just check what I've got done. Okay, that's fine. I need the square term inside the bracket, or outside the bracket inside the root. So let's just delete that, put that there, and put that there. That should do it now. And that gives us a 4.74 as we expected. So there we go. That's a basic introduction to the distance formula and the midpoint formula. If you haven't seen it before, what we'll now move on to is the main core business, as it were, of this particular unit, and that's the equation of a circle. So take-home points: when you're working with a circle, if in doubt, sketch it out. A little sketch helps. We've got a chord, a diameter, we've got a radius, a tangent, we've got the midpoint and the distance formula.